Extremely fast snow removal tools and machines. Skizee. The Skizee redefines powered skiing by blending alpine dynamics with electric propulsion. Designed as a ski-integrated drive system rather than a standalone vehicle, it incorporates two compact electric motors engineered specifically for sub-zero performance. These drive units are sealed within an enclosed drivetrain to prevent snow, slush, and ice intrusion, an essential requirement for reliability in winter environments. The system reaches speeds of up to 40 km per hour, approximately 25 miles per hour, delivering a controlled but energetic riding experience. Typical assisted cruising speeds range between 9 and 16 miles per hour, depending on terrain gradient and surface conditions. Energy is supplied by a high-capacity lithium battery pack that provides between 1.5 and 3 hours of runtime. Charging is achieved via a standard wall outlet, with optional fast charging configurations available. A handle-mounted throttle allows incremental power modulation, enabling precise torque control while carving or traversing flats. Safety engineering includes an automatic cut-off mechanism that disengages propulsion if the rider falls. Unlike snowmobiles, the rider remains upright and must actively manage balance, edging angles, and body positioning, preserving the technical feel of traditional alpine skiing while adding motorized assistance. Bobsla. The Bobsla is a compact electric snow machine that departs from conventional snowmobiles. Instead of skis at the front and a single rear track, it utilizes a rear dual-track propulsion system combined with a sled-style front platform that glides over snow surfaces. Powered by two synchronized electric motors generating roughly 16 horsepower, the machine achieves a top speed near 19 miles per hour. Electronic limiting ensures predictable acceleration and stability. Dual battery modules provide approximately 1 hour of runtime, with range varying between 6 and 18 miles depending on terrain and load. Steering is achieved not through handlebars connected to skis, but through differential track input and rider weight shifting. The seated position is low and centered, enhancing stability while encouraging a drifting-style riding dynamic. The absence of aggressive steering geometry makes it approachable even for users without skiing experience. 2025 Timbersled Ripper. The Timbersled Ripper continues the innovation of snow bike conversion systems pioneered by Timbersled. Instead of designing a separate snow vehicle, this kit transforms a dirt bike by replacing the front wheel with a ski assembly and the rear wheel with a trak drive module. The rear suspension employs a dual-arm configuration with internal floating piston, IFP, shocks, maintaining consistent track-to-snow contact across uneven terrain. Engine output is transmitted through a reinforced chain drive mechanism to the rear track, distributing weight across a larger surface area to prevent sinking. The front ski pivots with the bike's handlebars, preserving familiar steering feedback for riders accustomed to motocross geometry. This mechanical conversion enables year-round use of an existing motorcycle platform while adapting it to deep snow and winter trails. Heat Trak. The Heat Trak system approaches snow removal through thermal management rather than mechanical displacement. Instead of embedding heating cables beneath pavement, these mats are placed directly on top of concrete or asphalt surfaces. Operating on a standard 120-volt household outlet, the system uses a transformer to reduce voltage before delivering power to embedded heating elements. Medium-sized mats typically consume between 300 and 600 watts. When active, surface temperatures remain between 40 degrees Fahrenheit and 60 degrees Fahrenheit, preventing ice formation and melting snowfall at contact. Constructed with durable textured rubber and sealed internal heating cables, the mats improve traction while operating. Available in multiple sizes including stair-specific designs, they can be linked together and powered through a centralized control unit. Some configurations incorporate temperature-activated automation. RC Plus Snow Cruiser. The RC Plus Snow Cruiser is a fully enclosed tow-behind snow cabin designed for winter travel and camping support. Measuring roughly 10 feet long, 4 feet wide, and 5 feet tall, it supports payloads between 770 and 840 pounds. Movement relies on dual metal skis fitted with replaceable plastic runners and supported by shock-absorbing suspension. A standard 2-inch ball hitch allows compatibility with most snowmobiles. The outer shell is fabricated from fiberglass reinforced plastic for cold weather durability. Interior configurations include padded seating, harnesses, and optional modular cargo space. Large side windows enhance visibility, while structural reinforcements at stress points maintain integrity over rough terrain. Snowbot S1. The Snowbot S1 automates residential snow clearing using battery-powered propulsion and sensor-guided navigation. Weighing approximately 143 pounds, it operates on rubber tracks and clears snow up to 12 inches deep, projecting discharge up to 12 feet away. Runtime averages 90 minutes per charge, with recharge times near 2 hours. Under favorable conditions, it can clear approximately 1,500 square feet per session. A rubber-tipped auger feeds snow into a discharge chute, while LiDAR sensors and positioning beacons define operational boundaries. Safety mechanisms include automatic shutdown during auger jams, emergency stop controls, and audible alerts. Remote and app-based monitoring allow oversight without manual steering. Tucker Sno-Cat. The Tucker Sno-Cat, frequently seen at locations such as Mount Hood, operates on 4 independently mounted rubber tracks. Unlike traditional skid steer systems, steering occurs via hydraulic articulation of front and rear axles, allowing smooth directional arcs while maintaining traction. Diesel engines ranging between 130 and 210 horsepower power the vehicle. Its insulated and heated cab supports long operational shifts in ski resorts, research sites, and remote environments. Polaris Switchback. The Polaris Switchback combines trail and backcountry performance. Built on a centralized rider platform, it weighs approximately 497 pounds dry and carries 11 gallons of fuel. Front suspension travel measures 9 inches, while the rear provides 16 inches of movement paired with a 15x 146-inch trak. Adjustable ski stance, 39 to 41 inches, allows customization for terrain and rider preference. Electronic fuel management adapts to elevation and temperature changes. Rongo Icebreaker. The Rongo is a mechanical ice fracturing attachment powered solely by tractor movement. 2 sequential 47-inch cutting modules totaling 16 cutter wheels strike ice repeatedly using hardened blades mounted on spring-supported arms. Each 10-inch cutter wheel features 15 impact knives. The independent suspension design enables adaptation to uneven sidewalks, ramps, and pedestrian crossings without hydraulic hookups. Christy 458 FC. The Christy 458 FC operates using dual engines, one generating lift through an air cushion and the other providing thrust via rear propeller. A segmented skirt system maintains air containment beneath the hull. The enclosed cabin seats 4 passengers, shielding occupants from wind and precipitation. This hovercraft design enables traversal across snow, ice, and mixed terrain surfaces at highway comparable speeds. Avalanche Home Slider. The Avalanche Home Slider removes roof snow from ground level using an extendable 16-foot handle and wheeled slide panel. Rather than pulling snow downward manually, the device slides beneath accumulated layers, allowing gravity to release snow safely away from the structure. Train Snow Removal System. Heavy rail snow removal systems consist of specialized plow cars weighing up to 70 tons and measuring around 50 feet in length. Equipped with front plows and articulated side wings powered by pneumatic or hydraulic systems, they clear snow below rail height while dispersing accumulation far from tracks to prevent redrifting. These machines and tools demonstrate a broad spectrum of snow management technologies, from autonomous robotics and articulated track vehicles to thermal melting systems and advanced mechanical ice breakers. Each represents a distinct engineering approach to overcoming winter's operational challenges with speed, efficiency, and control. Add more. Below is an extended continuation with additional technical depth and more high-performance snow removal and winter mobility systems. Milwaukee registered M12 heated jacket. The Milwaukee M12 heated jacket integrates active heating elements directly into workwear, targeting professionals exposed to prolonged cold environments. Powered by the M12 lithium-ion battery platform, the jacket uses carbon fiber heating zones positioned across the chest, back, and pockets to deliver distributed warmth. 3 heat settings, high, medium, and low, are controlled via an illuminated push-button interface. On the lowest setting, runtime can extend to approximately 12 hours depending on battery capacity. The heating elements are engineered to warm the core areas first, which is thermodynamically efficient because maintaining torso temperature reduces overall heat loss. The outer shell is wind and water resistant, typically constructed from stretch polyester blends for flexibility during manual labor. Adjustable cuffs and waist closures reduce convective heat loss, while reinforced seams improve durability in demanding work environments such as snow clearing, construction, and municipal maintenance. Big Buddy Heater. The Big Buddy Heater is designed for enclosed or semi-enclosed winter spaces such as garages, ice fishing shelters, and workshops. It uses radiant heating technology, meaning it transfers infrared heat directly to people and nearby surfaces rather than relying solely on warming the surrounding air. It operates on propane, accepting either 2 1-pound cylinders attached directly to the front or connection to a larger external tank, example 5 pounds, or greater. Multiple heat output levels allow runtime optimization. On low settings, small cylinders may last close to a full day, whereas high output significantly reduces duration. Safety features include an oxygen depletion sensor, ODs, and tip-over auto shut-off. Push-button ignition simplifies startup, and a built-in fan, battery-powered, can help circulate warm air more evenly. Weighing roughly 17 pounds, it balances portability with meaningful heating capacity, often rated for areas up to 450 square feet under ideal conditions. AutoBoss Folding Snow Shovel. The AutoBoss is engineered for emergency vehicle storage and rapid deployment. Unlike traditional metal shovels, its molded polymer blade reduces cold conduction to the user's hands and resists corrosion. A central locking hinge allows it to collapse to approximately 16 to 17 inches in length, making it suitable for trunks and emergency kits. When deployed, the locking mechanism secures the shaft rigidly to maintain leverage while clearing snow around tires or wheel wells. Although it lacks a sharpened metal scraping edge, the shovel is effective for moderately compacted snow and light ice conditions commonly encountered when vehicles become partially stuck in winter parking scenarios. Elite Spin Snowshoes. The Elite Spin Snowshoes incorporate a dial-based tightening system, eliminating the need for manual strap threading. This ratcheting mechanism allows micro-adjustments even while wearing gloves, improving efficiency during cold weather use. The aluminum frame integrates sawtooth traction edges directly into its perimeter, increasing grip without requiring separate crampon attachments. The decking material, often referred to as tech weave, provides slight flex under load, enabling more natural gait mechanics while maintaining tensile integrity. Snowshoes like these distribute body weight across a larger surface area, reducing ground pressure and preventing post-holing in deep powder. Their torsional rigidity also improves lateral stability on sloped or uneven terrain. Rongo Mechanical Icebreaker. The Rongo attachment uses kinetic impact rather than scraping to fragment hardened ice layers. As the host tractor advances, mechanical rotation drives 10-inch cutter wheels fitted with hardened steel knives. Each cutting section spans 47 inches, and dual sequential sections ensure a double-pass fragmentation effect within a single forward movement. The spring-mounted arms allow vertical compliance, enabling each wheel to adjust independently to uneven pavement profiles. Because the system derives motion mechanically from tractor movement rather than hydraulic hookups, it simplifies installation and reduces auxiliary power demands. This design is particularly suited to municipal sidewalk clearing, pedestrian ramps, and freeze-thaw-impacted surfaces. Polaris Switchback Snowmobile. The Polaris Switchback bridges the performance gap between trail riding and deep snow maneuverability. Built on a centralized rider platform, it positions the operator's weight directly over the drive track to enhance control. With approximately 497 pounds dry weight and a 15x 146-inch rear track, it provides flotation in soft snow while retaining responsive trail handling. Adjustable ski stance, 39 to 41 inches, allows riders to modify stability characteristics. The engine management system automatically compensates for elevation and ambient temperature changes, maintaining consistent combustion efficiency. Suspension travel 9 inches front and 16 inches rear absorbs trail irregularities while preserving traction during acceleration. Train snow removal rail car. Heavy-duty rail snow plows represent industrial-scale snow management. These specialized rail cars, often around 50 feet long and weighing up to 70 tons, are equipped with adjustable plow blades and lateral wings. The front blade clears snow between rails, while extendable side wings displace accumulation farther from the track bed to prevent drift return. Cutting edges are set slightly below railhead height, ensuring removal of compacted snow without damaging steel rails. These units are typically pushed by locomotives rather than self-propelled. Operator visibility is enhanced by elevated cabs with panoramic windows, essential for monitoring track alignment and obstructions during severe winter storms. Avalanche Home Slider. The Avalanche Home Slider offers a gravity-assisted approach to roof snow clearing. An extendable aluminum handle, up to 16 feet, connects to a wide slide panel mounted on small wheels. Rather than dragging snow downward manually, which increases physical strain, the tool is pushed upward beneath the snowpack. Once the panel is in position, gravity causes accumulated snow to slide down along the plastic chute safely to the ground. This reduces roof loading stress and lowers risk compared to climbing onto icy surfaces. Christy 458 FC Hovercraft. The Christy 458 FC utilizes dual-engine architecture. One engine powers a lift fan generating an air cushion, while a second drives a thrust propeller for forward motion. A segmented skirt system retains pressurized air beneath the hull, allowing operation across snow, ice, shallow water, and marshland. The enclosed cabin accommodates 4 occupants and shields them from environmental exposure. Hovercraft technology excels where terrain transitions between ice, open water, and snow conditions that challenge wheeled or tracked vehicles. Snow removal engineering overview. Across these technologies, several engineering strategies dominate winter mobility and snow management. Thermal mitigation, heated mats and wearable heating systems prevent accumulation or preserve operator endurance. Mechanical displacement, plows, augers, cutter wheels, and sliding panels physically relocate snow. Impact fracturing, systems like Rongo break ice through repeated kinetic strikes. Flotation and weight distribution, tracks, skis, and wide platforms reduce ground pressure. Autonomous navigation, robotics like Snowbot S1 apply sensor fusion and programmed boundary mapping. Air cushion lift, hovercraft eliminate surface friction by riding on pressurized air. Collectively, these machines illustrate how winter engineering balances traction, flotation, power transmission, thermal management, and operator safety. Whether at the scale of municipal infrastructure or residential driveways, modern snow removal equipment is increasingly specialized, efficient, and technically sophisticated. Add more. Below is a further expansion, adding additional high-speed snow removal systems, winter mobility platforms, and deeper engineering analysis. Tire socks. Tire socks provide a lightweight alternative to traditional metal tire chains. Constructed from high-friction woven synthetic fibers, these textile covers increase the tire's coefficient of friction on snow and light ice surfaces. Unlike chains, which rely on metal links to bite into ice, tire socks work by absorbing surface moisture and improving micro-level grip between the rubber tire and frozen ground. Installation involves stretching the fabric over the tire's upper section, rolling the vehicle slightly, and completing the fit. Elasticized edges help maintain alignment during rotation. They are typically speed rated up to approximately 30 miles per hour and are designed for temporary use in snow-covered conditions only. Because they contain no metal components, they generate minimal vibration and are often compatible with vehicles where wheel well clearance prevents chain installation. Each set is size specific, example 205/55R16, matching tire width, aspect ratio, and wheel diameter. Snowype Automated Snow Clearing System. The Snowype takes a preventative approach to snow buildup. Instead of removing large accumulations after a storm, it operates during snowfall to prevent significant accumulation. The system consists of a motor-driven blade housed within a sealed weather-resistant casing. Mounted along modular tracks, it can be installed across flat or inclined surfaces such as walkways and driveways. Sensors measure snowfall rate and ambient temperature, transmitting data to a central control unit that determines operational timing. By clearing snow continuously as it falls, the system reduces ice layering caused by melt, freeze cycles. Because it avoids heavy buildup, its energy consumption is typically lower than that required for large-scale mechanical removal after accumulation. Snow shovel with wheel assist. Wheel-assisted snow pushers represent an ergonomic refinement of manual snow clearing. These wide blade shovels, typically 30 to 36 inches across, are designed for pushing rather than lifting snow. Integrated wheels carry the majority of snow weight, significantly reducing lumbar strain. From a biomechanics standpoint, this approach minimizes repetitive spinal flexion and torsional loading. The user maintains a more neutral posture, translating force horizontally rather than vertically. Constructed from molded high-impact plastic with a curved front edge, the blade glides across concrete without gouging surfaces. While effective for fresh and moderately packed snow, very dense or icy accumulation may require supplementary tools. ENVO Snow Kart. The ENVO Snow Kart offers a low-speed electric mobility solution for snow-covered environments. Powered by a 48-volt electrical architecture, it uses dual rear hub motors delivering a combined output of approximately 2,000 watts. Energy is stored in a removable 840 Wh battery pack. Under favorable conditions, it achieves speeds up to 12 miles per hour and a range approaching 31 miles. Rear propulsion comes from twin tracks, while a single front ski guides steering. Weighing about 99 pounds and rated for riders up to roughly 265 pounds, it provides accessible winter recreation with simplified controls. Regenerative braking returns a portion of kinetic energy to the battery during deceleration, enhancing efficiency. Fat bike skis. Fat bike skis replace the traditional front wheel of an electric or pedal-powered fat tire bicycle with a wide ski assembly. Typically measuring 3 to 3.5 feet in length and just over 4 inches in width, the ski distributes load across snow surfaces to prevent front-end sink. The rear fat tire, often 4 to 5 inches wide, remains in place, preserving drivetrain familiarity. Most systems attach directly via standard axle dimensions and may include adapters for varying fork standards. Riders often begin with a front ski-only configuration, as the wide rear tire already provides flotation and traction. Sno-GO Ski Bike. The Sno-GO Ski Bikes combines bicycle ergonomics with ski-based carving dynamics. Unlike seated snow bikes, this platform positions the rider upright over 3 coordinated skis, 1 front, 2 rear. The skis are mechanically linked so that steering input and body lean synchronize edge engagement across all 3 contact points. Weighing approximately 48 pounds, the system relies entirely on gravity for propulsion. A front suspension fork absorbs terrain irregularities, while braking is achieved by increasing edge pressure rather than mechanical braking components. This creates a carving sensation closer to alpine skiing than sliding. Yooner Seated Ski. The Yooner Seated Ski offers a low center of gravity alternative to traditional skiing. Positioned roughly 20 centimeters above the snow, the rider sits while guiding a single carving ski beneath. Control is achieved through body weight shifts and subtle handle input. Speed reduction occurs by lightly dragging feet or engaging ski edges through lean angles. The seated configuration lowers the balance threshold, making it accessible to beginners while still providing carving dynamics on groomed slopes. Slegoon. The Slegoon is a molded, enclosed frame snow descent craft. The rider sits inside a rounded shell rather than atop a flat sled. Its curved exterior profile allows continued sliding even if partial roll occurs, reducing abrupt stops. The seat reclines slightly, keeping the rider's center of mass low and stable. Constructed primarily from durable plastic composites, it emphasizes structural resilience and controlled downhill travel without mechanical propulsion. Engineering themes in high-speed snow management. Across all systems described: manual, motorized, electric, hydraulic, or air cushion-based, several engineering principles consistently appear. 1. Load distribution. Tracks, skis, and wide surfaces reduce ground pressure, preventing vehicles from sinking into powder. 2. Traction enhancement. Textile tire covers, integrated traction frames, and edge-based carving systems increase surface grip without excessive mechanical complexity. 3. Energy efficiency. Electric propulsion systems, Skizee, ENVO Sno-Cat, prioritize battery management, regenerative braking, and sealed drivetrain designs to maximize cold weather reliability. 4. Ice fracture versus ice melt. Some systems break ice mechanically, Rongo, while others prevent formation thermally, heat trak. Each method addresses different environmental constraints. 5. Operator safety and ergonomics. Wheel-assisted shovels reduce musculoskeletal strain. Heated apparel extends safe exposure duration. Enclosed cabins protect occupants from wind chill and precipitation. 6. Autonomous operation. Robotic systems such as Snowbot S1 leverage sensor fusion, boundary mapping, and feedback control algorithms to operate independently. Modern snow removal and winter mobility technologies are no longer limited to plows and shovels. From autonomous robots and hovercraft to textile traction devices and kinetic ice breakers, winter engineering continues to evolve toward faster, safer, and more energy-efficient solutions. Add more. Below is a further expansion with additional high-performance snow removal equipment, heavy-duty infrastructure machines, and advanced winter mobility technologies. Snow blower systems, single-stage and two-stage. Modern snow blowers remain one of the fastest residential snow removal solutions. Single-stage units use a high-speed rubber or steel auger that both gathers and throws snow in one motion. These machines are typically best for light to moderate snowfall on paved surfaces because the auger makes direct contact with the ground. Two-stage systems add an impeller behind the auger. The auger collects snow and feeds it into the impeller, which then ejects it through a chute at high velocity. This configuration significantly increases throwing distance, often 30 to 50 feet, and enables clearing of snow depths exceeding 18 inches. Many professional models include self-propelled drive systems, multiple forward/reverse speeds, heated handles, electric start for cold reliability, drift cutters for compacted roadside buildup. Track drive versions further improve traction on steep driveways and icy surfaces by increasing contact area and reducing slippage. Rotary snow plows, rail and highway use. Rotary snow plows represent one of the most aggressive snow removal technologies used in rail corridors and mountainous highways. Unlike wedge plows that push snow aside, rotary plows use a massive front-mounted spinning fan, often 8 to 12 feet in diameter, to cut directly into deep drifts. The rotating blades funnel snow into an internal chamber and discharge it through a directional chute capable of projecting snow over 100 feet away from the clearing path. This is particularly critical in alpine railways where snow banks can exceed several meters in height. Because of their extreme power requirements, rotary plows are typically pushed by multiple locomotives. Their advantage lies in their ability to reopen rail lines buried under avalanche debris or wind-packed drifts. Airport snow sweepers and multifunction plow units. Airports require high-speed, wide-area snow removal to keep runways operational. Specialized multifunction snow removal vehicles combine plows, rotary brooms, and air blowers into one integrated unit. A typical configuration includes front plow blade to remove heavy accumulation, high-speed rotary broom to sweep residual snow, air blast system to clear fine particles and moisture. These machines can operate at speeds exceeding 30 miles per hour while clearing widths greater than 20 feet per pass. The objective is not just snow removal but restoring optimal runway friction coefficients for aircraft braking performance. Hydraulic systems allow rapid blade angle adjustments and broom pressure control depending on snow density. Hydraulic snow plow attachments for trucks. Heavy-duty truck-mounted snow plows remain foundational in municipal snow operations. These plows are typically constructed from reinforced steel or polyethylene moldboards and can be straight blade, V-plow, adjustable wing angles, expandable wing plows, box plows for containment. Hydraulic rams control blade height and angle from inside the cab. Down pressure systems improve scraping effectiveness on compacted snow. V-plows are particularly efficient in deep accumulation because they can split drifts in V mode or windrow snow to the side in angled mode. Some modern systems integrate smart controllers that automatically adjust blade pitch based on surface resistance. Salt and brine spreader systems. Mechanical removal is often paired with chemical ice control. Tailgate or hopper-mounted spreaders distribute rock salt, calcium chloride, or liquid brine across road surfaces. Liquid brine pretreatment has become common because it prevents ice bonding to pavement. Anti-icing reduces the mechanical force required later for plowing. Modern spreaders feature variable flow rate control, Ground speed sensors. GPS-based application tracking. Corrosion-resistant poly hoppers. Efficient chemical application reduces environmental impact while maintaining road safety. Snow groomers, trail and ski resort preparation. Snow groomers, often seen in ski resorts, are large tracked vehicles designed to compact and texture snow rather than remove it. Front blades level uneven terrain while rear tillers mill and redistribute snow to create smooth ski surfaces. The tiller's rotating drum breaks up ice chunks and aerates snow before compressing it. Wide rubber tracks distribute weight evenly, preventing excessive sinking while allowing the machine to climb steep slopes. Many groomers feature winch systems for stabilizing on extreme inclines. Electric snow removal equipment. Battery-powered snow blowers and plows are gaining traction due to reduced emissions and lower maintenance. High-voltage lithium battery packs now rival small gasoline engines in torque output. Advantages include instant start in freezing temperatures, no fuel storage concerns, reduced vibration, lower acoustic footprint. Cold weather battery management systems regulate temperature to prevent performance degradation. However, runtime remains dependent on battery capacity and snow density. Heated driveway systems, embedded hydronic and electric. Unlike surface heating mats, embedded snow melt systems are installed beneath concrete or pavers. Two primary systems exist. Hydronic systems circulate heated glycol water mixture through tubing. Electric cable systems, resistive heating wires embedded in substrate. Sensors detect moisture and temperature, automatically activating the system when freezing precipitation begins. These systems prevent snow accumulation entirely, eliminating manual removal. While installation cost is higher, operational efficiency improves long-term property safety and reduces slip hazards. Snow vacuums for urban environments. In dense urban areas where snow cannot simply be pushed aside, industrial snow vacuums collect snow and transport it to melting facilities. Large suction hoses mounted on trucks vacuum snow from sidewalks and loading zones into onboard containers. Snow is then dumped into heated tanks or transported away for disposal. This method is especially useful in cities with limited snow storage space. Advanced engineering concepts in snow removal. 1. Surface pressure optimization. Ground pressure, weight divided by contact area, determines flotation. Tracks and skis increase area, reducing penetration into soft snow. 2. Thermal transfer efficiency. Heated systems rely on conductive and radiant heat transfer. Efficient insulation reduces wasted energy. 3. Kinetic energy deployment. Rotary plows and augers convert mechanical energy into high-velocity snow ejection. Blade geometry directly affects discharge efficiency. 4. Autonomous navigation and sensor fusion. Modern robotic systems integrate LiDAR, ultrasonic sensors, IMU gyroscopes, and GPS mapping to navigate complex driveways. 5. Materials engineering. Cold-resistant polymers prevent brittleness at sub-zero temperatures. Hardened steel cutting edges resist abrasion from sand and ice. 6. Human factors engineering. Ergonomic controls, heated grips, vibration damping, and improved visibility reduce operator fatigue during extended winter shifts. The evolution of winter technology. Snow management has evolved from manual shoveling to intelligent, sensor-driven systems capable of handling extreme accumulation. Whether through mechanical displacement, thermal prevention, autonomous robotics, air cushion mobility, heavy industrial rotary cutting. Modern snow removal equipment reflects advancements in materials science, battery technology, hydraulic systems, and environmental engineering. As climate patterns continue producing unpredictable winter events, the demand for faster, more efficient, and safer snow removal solutions will continue driving innovation across residential, municipal, and industrial sectors.